Hello class. So this week we've been learning about electromagnetic induction. So what I want to do is give you an idea of how a generator works based on electromagnetic induction. We're going to talk about very basic generator action. All right. So first of all, here's what we've got. We've got our magnetic field. We've got a magnet, or two magnets rather. We've got a north pole facing a south pole. So we know that our flux lines are traveling this direction, and between the two magnets we've got multiple flux lines, okay? Inside our magnetic field we've placed a conductor that we're going to spin in this direction, okay? We're going to start at 0 degrees, we're going to move to 90 degrees, 180 degrees, 270 degrees, and we're going to make one complete revolution as we do this, as we travel along. So what I want you to do is, I want you to focus on this point right here, this white dot right here. That's our focal point. Because as this spins, we're going to see how this cuts through our flux lines and induces a voltage in the conductor. So imagine, if you will, we're spinning our conductor. All right, so this point begins to move. Now, initially, because of how it's positioned, this point right here is kind of traveling in parallel with my flux lines. In other words, it's not cutting through any flux lines. As we move away from the 0 degree mark towards the 90 degree mark, notice that from about here to here, we start cutting through more flux lines in a given area. So the more flux lines we cut through, the more induced voltage we have. So here's what's happening. We're going from 0 degrees to 90 degrees, and as we do, our voltage is increasing from 0 up to its peak, which is where we'll be at the 90 degree mark. We've cut through the most flux lines right in between this point right here. Now, as we move away from the 90 degree mark towards the 180 degree mark, notice that all of a sudden we begin to cut through fewer flux lines, and we begin to kind of move with the flux lines in parallel once again. So we increase as we move toward 90 degrees. At the 90 degree mark, we've peaked, and then we begin cutting through fewer flux lines until we're right back down to 0 volts, all right? So now our focal point has changed positions. I want you to focus on this point right down here now. So as we now move from the 180 degree mark towards 270 degrees, it's the same ideas took place up here. Initially, we're moving parallel with our flux lines. In other words, we're traveling with them, so we've got little or no voltage until we get about here and start cutting through more flux lines. As we cut through more flux lines, our voltage increases, but notice, I was cutting through the north pole here. Over here, I'm cutting through the south pole, which is going to create the same effect as this side, except it's going to cause current to increase in the opposite polarity. All right, so as I move toward the 270 degree mark, I reach my peak at 270 degrees. I continue toward the 360 degree mark. Once again, I begin cutting through fewer flux lines, moving away from 270 to 360, and I'm right back to 0. So this represents one complete revolution. All right? So now, what I've done is, I have induced a voltage over a certain period of time. One thing you need to understand, voltage measurements are always up and down. Time measurements are always side to side. So here it is, ladies and gentlemen, basic generator action, and I mean this is basic generator action. So let's take a look at a practical application of basic generator action. So what I've got here is, I've got an AC generator. No, I didn't build this one. I bought it already put together, but it'll do the same job as if I had built it. Now, what I've got here is, I've got my generator, and I have it connected to an oscilloscope. This is a piece of equipment that we're going to learn about at a later time, and we're going to learn this in pretty good detail. We're going to learn how to use it a little bit later on this term. So what we're going to do is, we're going to go through and explain how this works, and then I'm going to show you what's produced as we put this thing to work. Okay, folks, so here we are. Here's my North Pole, here's my South Pole. North Pole is always represented by red, South Pole is always represented by blue. We know that our flux lines are traveling from north to south. We learned that in our magnetism lesson, all right? And so here's my conductor inside the magnetic field. This is going to be our focal point, just like the point that we used on the board. Right now, my conductor is wrapped around in this way. So right now, these coils are in parallel with my flux lines, which are traveling this way. So my coil is traveling this way, my flux lines are traveling this way, okay? So that means that right now, I would have 0 volts produced by this generator, okay? Now, as my point here begins to turn in this direction, we begin to spin it in this direction. Here we are, we're moving away from the 90-degree mark, moving towards, or excuse me, the 0-degree mark, moving towards the 90-degree mark. Right here, we're now cutting through more flux lines. Does that make sense? See here, we weren't cutting through any, but now that we begin to move into the magnetic field, here's where we start cutting through more flux lines. At this point, the 90-degree point, we're at our maximum, we're at our peak, okay? So now, from here, we move away from the 90-degree mark to the 180-degree mark. Right down here, once again, we're moving parallel with our flux lines. So again, I'm back to 0. So I started at 0 at this point. I began cutting through the most flux lines in this area here. At this point right here, I reached my peak, and now I'm moving away in the same direction of those flux lines, and I go back down to 0. Then from 180 degrees, I move toward the 270 degree mark, but notice instead of cutting through the North Pole side, now I'm cutting through the South Pole side. The North Pole side will cause current to flow one direction. The South Pole side will cause current to flow the opposite direction, or the North Pole side will induce a voltage in one polarity. The South Pole side will produce a voltage in the opposite polarity. So I move from 180 degrees toward the 270 degree mark. At 270 degrees, I reach my peak. Once again, I move away from 270 degrees towards the 360 degree mark. I have now made one complete revolution, and in doing so, I have created one alternation and then a second alternation in the opposite polarity. Okay, so now that we've got that understanding, let's take a look here. So what I've got is, I've got this connected to my oscilloscope. So as always, your black lead, whether it be your multimeter, whether it be an oscilloscope or whatever, the black lead is always your point of reference. So what we're going to do is, we're going to monitor this side here, the red side, with respect to the black side. So what's going to happen is, we're going to see that we're going to get an increase and then in one polarity, and then an increase in the opposite polarity. Okay, so now we've gone through all of that, so let's actually make this work. I'm going to spin it in a clockwise direction and take a look at that oscilloscope screen. That's the waveform being produced as I spin my conductor in that magnetic field. One important thing to understand, I could just as easily have this fixed to where it won't move and have the magnets spinning around it, and it would produce the exact same effect. So there we have it, folks. That's electromagnetic induction at work and basic generator action.